linear equation. So we're going to deal with an equation that has some fractions involved. So let's remember our step for linear equations. First, we need to clear the fractions or the parentheses, combine like terms in each side before start moving the equation, and then get our variable isolated. So in this type of equation, we have fractions involved, which means we need to get rid of them. Let's clear them. And how are we going to achieve that? Is by finding the L.C.D, finding the least common denominator between 15, 5, and 3. So on the side, let's do that. 15, 5, and 3. So use any method for your choice to find the L.C.D. So in this case will be 3 times 5, and this is a 5, and this is a 3. So to get the L.C.D, I'm going to choose one set, which in this case will be 15, well, which is 3 times 5. Then this 5 is already included, and this 3 is already included. Therefore, the L.C.D is 15. So to get rid of the denominators, we need to multiply by the L.C.D every single term. This is 1 term, 2 terms, and 3 terms. So let's get rid of them. 15 over 1 times 1 over 15x minus, well, we need to multiply it times 15 as well. 15 over 1 times 4 over 5 equals to 15 over 1 times 2 over 3. Now the reason why we do this is because we're trying to eliminate the denominators. Look, 15 goes into 15 how many times? Once. So they're pretty much gone. And what are you going to be left with is one single x. Same idea. 5 goes into 15 how many times? 3 times. So you're left with negative 3 times a 4 equal. 3 goes into 15 5 times. Therefore, you're left with 5 times 2. Now, we need to clear the parentheses. I mean, you could have done this in one step, like 3 times 4 give you 12, but if you take one extra step, it's not going to hurt you. It might take you, what? It might take you, what, 1 minute more? But until you get used to it, until you see the pattern, then you will start realizing, okay, I can just skip that step. But for now, to be safe, let's do it step by step. So let's clear the parentheses. In this case comes x, negative 3 and a positive 4 give you a negative 12 equal 5 times 2 is equals to 10. Now we gotta combine like terms in each side of the equation, which in this case there is no like terms in each side of the equation. Now let's move. The third step is to get the variable isolated. We need to isolate for x, which means leave that alone, either in the left side or in the right side. Well, I have that negative 12 that is there next to the x, so I might just want to get rid of that number by adding 12. So plus 12 plus 12. Why do we add 12? Is because negative 12 and a positive 12 will cancel out, and what I do to one side I have to do it to the other side in order to keep our equation evenly, like to maintain that balance in an equation. So what are we left with? X by itself, because this will go away, right? Now positive 10 and a positive 12 give you a 22. Therefore, we're done with our equation. X equals to 22.